Welcome to you all. Hope that this session will give you more explanation on project network analysis. This video is a continuation of previous video as a part of the network analysis, thus covering the following as main titles: Introduction, PERT, and Probability in PERT. Also, you are hereby advised to relatively watch my previous video to get more understanding as a preliminary requirement for this video from the link given. In this video, we mainly cover the determination of time for an activity and its related project with their respective probability for an expected completion duration. One of the main objectives of network analysis is to determine the duration required to complete a project. This implies that how long a project will or can take for its completion. Hence, this paper has aimed to provide the ways to determine duration and its related probability in the network analysis. This video is therefore organized with an introduction to Program Evaluation and Review Technique, PERT, in view of determining activity duration and its respective probability. Program Evaluation Review Technique, PERT. This technique PERT consists of, primarily, time estimation. This is to explore the ways of determining the expected time of completing an activity and the project. The next is the probability determination. This is to statistically determine the probability of completing an activity and the project within the expected time frame. Now, we can move on detailing the PERT. An introduction to PERT. The PERT is a project management technique, where the activities are arranged in their sequential order of completion towards completion of the project. The PERT insists how a project can be completed in a possible and reasonable time. The PERT has the capacity of managing the activities with their completion duration. For example, though there is a possibility for completing an activity in 4 weeks, the PERT facilitates to determine the probabilistic possibility of completing the activity within a range of weeks from 3 to 8. The main objective of the PERT is to determine the probability of completion duration of a project within a time frame. Time estimation. After determining the activities and their sequential order of completion with their prerequisites in a project, it is important to estimate the completion time of each and every activity in the project. Generally, there are 2 approaches in practice for estimating the completion time of an activity. They are: first, single time-based estimate. This refers to particular, single completion duration for an activity, and second, multiple time-based estimate. This is to estimate the completion duration of an activity, based on its various possible completion times that are associated with different nature. Unit of estimation. The application of unit of duration is based on the size of a project. The next is the unit of duration of an activity that can be in terms of minutes, hours, days, weeks, months, or years. Therefore, it is important to apply a unique unit of duration for all the activities in the project. Also, you must know about the main features of PERT. Referring to multiple time-based estimate involves with various completion time of an activity, respectively with different nature, thus implying to consider the probabilistic nature of the particular activity duration. Therefore, the PERT has 2 features. They are namely multiple time-based estimates and probabilistic activity durations. Multiple time-based estimates, MTBE. As assumed that completion duration of an activity cannot be a single measure, it follows a probability distribution. Therefore, the completion duration of the activity is an estimate of its multiple time completion durations. For every activity in relation to its completion, optimistic duration known as A, most probable duration known as M, and pessimistic duration known as B, needs to be estimated, and these durations are used to estimate a weighted average duration of the activity as being completed. Next is the types of multiple times used for estimating the activity duration. First, optimistic duration, known as A, the possible minimum completion duration of an activity, where the interacting elements of the activity become feasible in favor of completing the activity, that is, the completion time the activity would take if things go well. Second, most probable duration, known as M. This is the possible moderate completion duration of an activity, where the interacting elements of the activity as a whole become feasible on a neutral phase, that is, the consensus reasonable estimate of the activity duration. And third, pessimistic duration, known as B. The possible maximum duration to complete an activity, where the interacting elements of the activity do not have a favorable state of activity completion, that is the completion time that the activity would take if things do not go well. Determination of an activity duration and example. Based on the above durations of an activity A, the weighted average, mean or expected, completion duration of the activity A can be determined by time of activity A equals to the sum of a plus 4m plus b that is divided by 6. For example, consider following 3 completion durations for activity A in a project. Optimistic duration, known as A, equals 12 days. Most likely duration, known as M, equals 15 days. And pessimistic duration, known as B, equals 24 days. Using the above formula and durations, the weighted average, mean or expected, completion duration of activity A can be determined as time of activity A equals to the sum of 12 plus 4 times 15 plus 24 that is divided by 6, and results in 16 days. Note that the derivation of average or mean duration of an activity as a single measure indicates that there is no major difference between them. As the PERT is concerned, it is possible to carry out further analyses, in particular, the determination of probability of activity or project completion duration, since multiple time estimates are in place. Probability in PERT. According to the PERT, the above 3 durations of an activity are considered as consistent with the normal distribution. Thus, the completion mean duration of an activity accounts 50% probability in the normal distribution. In the example, activity A has the completion durations 12, 15, and 24 days as optimistic known as A, most probable known as M, and pessimistic known as B, respectively, and its mean completion duration, known as TA, is 16 days. This implies that the probability of completing activity A in 16 days is 50% in the normal probability distribution. See the figure for details. Consistently, the deviations from mean completion duration are also subject to normal probability distribution. Therefore, the standard deviation of the particular activity A is important to assess the standard normal deviation, given as ZA. To assess the probability of deviation of the given duration, say XA, from mean duration of activity A, known as μA. Here, standard deviation sigma of activity A equals to the difference between pessimistic duration B and optimistic duration of the activity A divided by 6. Similarly, the variance is known as the squared value of the standard deviation. Probability of completing activity A within a given duration, XA, can be determined by measuring the standard normal deviation, ZA, for the given period together with the normal distribution table, available in most of the statistics books. Thus, ZA equals to the difference between expected given completion time, XA, and mean duration, μA, divided by standard deviation of activity A. Example has the mean completion duration of activity A equals TA equals μA equals 16 days. To determine the probability of completion duration of activity A within 19 days, the following normal distribution figure is useful to provide a clear understanding. From normal distribution table, the probability of completing activity A between 16 and 19 days is given by probability of ZA equivaling 1.5 equals 0.4332. To determine the probability of completion duration of activity A within 19 days, the probability of below 16 days, 0.5000, needs to be added to the probability P, Z equals 1.5, equals 0.4332 of completion duration, between 16 and 19 days. Thus, the probability of completing activity A in 19 days is probability of completion duration of activity A less than or equal to 19 is equal to 0.5000 plus 0.4332, that is equal to 0.9332. Consistently and similarly, for the project concerned, to determine the probability of completion duration between mean completion duration, μA, and given, proposed or targeted, duration, xp, of a project as a whole, the standard normal deviate, ZP, of the difference of the durations needs to be calculated with the formula for ZP. Thus, ZP equals to the difference between expected given completion time, XP, and mean duration, μP, divided by standard deviation of the project. In a general format, the normal distribution of the project duration can be shown for you as a figure next. Duration of the project TP is basically considered as the mean duration, P, of the project, so that P equals TP. As the expected completion duration of the project is considered as XP, the standard normal deviation for the given completion time is known as ZP, and its related probability around the mean duration is shown with shaded area, whereas at P equals to the difference between expected given completion time, XP, and mean duration, μP, divided by standard deviation of the project. It is clear that the probability for the ZP is available only for the area between the durations TP and XP. If you need to determine the probability of duration less than or equal to XP, you have to add left side probability of 0.5000 to the probability of ZP that is covered by the shaded area on the right. Thank you for watching this video. If you find this video is useful and or need more clarification, you may leave a comment about your thoughts. Also, my next video will give you an example of this topic. Your valuable comments can make me producing other related videos meaningfully with your support. Thank you in advance for your comments to be made.